Picture threading a needle from the other side of a football field, except the needle is moving at 18,000 kilometers an hour. You're aiming from 100 million kilometers away, and you only get one shot. No do-overs, no second pass. That's basically what Japan just pulled off. And the payoff wasn't just a successful maneuver. It was a photograph of something that shouldn't really look the way it looks. The spacecraft is called Hayabusa 2. If that name sounds familiar, it's because this thing already has one of the best resumes in space exploration. Back in 2018, it landed on an asteroid called Ryugu, grabbed a physical sample, and flew it back to Earth in 2020. One of the only times in human history anyone has done that. Mission accomplished. Job done. Most spacecraft would get retired at that point. Hayabusa 2 didn't retire. It kept flying. JAXA, Japan's space agency, still had a working spacecraft with fuel left in the tank, so they gave it a new job, an extended mission, unofficially nicknamed Hayabusa 2 Sharp. The idea was simple on paper. Use the leftover propellant to visit more asteroids along the way, purely as a bonus round. One of those bonus targets was a rock called Torifune. Here's where it gets interesting. On July 5, 2026, Hayabusa 2 sped past Torifune at a relative speed of about 5 kilometers per second. To put that in perspective, that's roughly 18,000 kilometers an hour. Fast enough to cross the length of Japan in under 2 minutes. And the spacecraft didn't just fly past at a safe, comfortable distance. It threaded itself to within about 800 meters of the surface. On purpose. Why get that close? Because Hayabusa 2 was never built for flybys. It's a rendezvous spacecraft, designed to slow down, match orbits, and hover. It doesn't have the long-range telescopic instruments that flyby probes usually carry. If it wanted a clear picture, it had no choice but to get dangerously close, correct its aim in real time, and hope the trajectory held. One member of the mission team later admitted the flyby was a genuinely risky operation. Nobody knew exactly what Torifune's shape or surface looked like beforehand. Get the geometry wrong, misjudge the asteroid's position by even a little, and there's no gentle outcome. You either miss the shot entirely, or you don't miss at all in the worst possible way. They didn't miss. And what came back was stranger than anyone expected. Torifune isn't a simple, round space rock. The images show something that looks almost like a peanut, or a snowman with two connected heads, two distinct lobes fused together, roughly 450 meters across in total. That's not a coincidence of shape. It's called a contact binary, and here's what that actually means. At some point in the past, two separate asteroids were orbiting each other, slowly spiraling closer and closer, until gravity finally pulled them together into one object. They didn't shatter on impact. They merged. What Hayabusa 2 photographed is essentially two former worlds, welded together, still wearing the shape of their collision. And this isn't some rare oddity. Scientists think contact binaries like this might actually be common among near-Earth asteroids, which raises an uncomfortable question. How many of the space rocks we track are actually two objects pretending to be one? That question matters more than it might seem. Because Torifune isn't just floating in some distant, irrelevant part of the solar system. It's part of the Apollo group, a family of near-Earth asteroids whose orbits actually cross Earth's own path around the Sun. It swings around the Sun roughly every 383 days and spins on its own axis about once every 5 hours. It's a neighbor. Not a threat, not on a collision course, but a neighbor. One whose exact shape, mass, and structure were basically unknown until 11 days ago. That unknown shape is exactly why this flyby wasn't just a photo opportunity. If humanity ever needs to deflect an asteroid, nudge something dangerous off a collision course before it becomes a real problem, The success of that mission depends entirely on things we can't guess from a telescope on Earth. Is the asteroid solid rock or a loosely packed pile of rubble? Is it one object or secretly two fused together? Push on the wrong kind of surface, and instead of gently deflecting it, you could fracture it or barely nudge it at all. This flyby was partly a real-world rehearsal for exactly that scenario, testing how precisely a spacecraft can navigate and image a target it knows almost nothing about, at high speed, with no second attempt. JAXA's own engineers didn't undersell how difficult it was. One of the mission leads compared the accuracy of the maneuver to tossing a coin and having it land exactly where you aimed, from across the entire country. That's the kind of precision this required. And they hit it. So what happens now? Hayabusa 2 isn't done. It's already past Torifune, still coasting on fuel reserves that are running low. Less than half its original propellant remains. The plan is for it to swing back past Earth in December 2027, then again in 2028, using our planet's gravity like a slingshot to line up its next and final target. A tiny asteroid called 1998 KY26, barely 11 meters across, spinning rapidly. Expected sometime around 2031. That's still years away. What we have right now is a single, sharp image of two ancient worlds fused into one, silently orbiting near Earth, that nobody had ever seen up close before last week, and maybe that's the part worth sitting with. We like to think we've mapped the neighborhood, that the asteroids near Earth are catalogued, understood, filed away as known quantities. Torifune is a reminder that we mostly know their orbits, not their nature. We know where they are. We're only just beginning to learn what they actually are. This wasn't a warning. Nothing about Torifune puts Earth at risk. But it was a rehearsal, for the day something out there might actually require one. And it worked.